basically. Then we'll cover options. The mathematics of options, the way we do it is going to be pretty elementary. Even though the valuation of options is incredibly complicated. But we're just going to do the application of it. And then you will have to do futures kind of on your own, but at a very elementary level. So that is going to be your last exam. Your last exam is going to have basically only 3 topics and a quarter. That's about it. And then the final, comprehensive. So we're pretty much done. All right, so last time we talked about bonds, and so we said, if you look at from the investor's perspective, a bond is a contract that promises a stream of payments. Those payments are called coupons, and at the end, the bond makes a lump sum payment for par, right? So if you invest in a bond, all you need to do is read the contract, and pretty much this is what you're being promised. Now, if you assume that this bond actually complies with the promise they're making, we said we can value a bond as the sum of, help me out, the sum of the
coupon present.
No, sum of the, at least I didn't hear one word that is very important. It goes before the word coupon. Is the sum of, is this coupon worth as much as this one? If you say yes, I want to do business with you now. No? Why not? Why is this coupon different than this one?
Time value of money.
Time value of money. So every time you compare quantities at different point in time, what do you have to do?
Discount them.
Discount them. So it's the sum of the,
Discounts?
no.
The discounted coupon payments.
In other words, to say that, is the sum of
Present
the
value.
present values of coupon payments and present value of par. Yeah? So in words, this is the way you compute the value of something. In fact, if you remember stocks, how do we compute the value of a stock? Instead of coupons, what do we have?
Dividends.
Dividends, or what do we do?
The sum of the present
We
value.
added the present value of the forecasted dividends, right? Because those we have to guess what they are. They're not written in a contract. And pretty much the logic is the exact same. Okay? This is easier because you have to do no forecasting. All you need to do is just read the contract, and you can construct the timeline. So in mathematical terms, this boils down to the sum of the present value of the coupons, take some discount rate. This is the present value of the first coupon, present value of the second coupon, and then at the end, you get that, and then you have to add par. Yeah. So we said, well, this is the same structure as an annuity and a lump sum. So if you want to calculate the value of a bond, you can use the financial calculator, and you're going to use the combination of annuity and lump sum. So with the calculator, the way you compute this is we're looking for the present value. So this is the number of coupon payments. IY is the periodic rate, periodic interest rate. This is going to be your periodic coupon, and this is par. So when you do this with a calculator, essentially you're doing this. Now we then use this in a bunch of different scenarios, and we developed 2 relationships. The first one relates the price of the bond to bond yield. Think of them as a specific word applied to bonds, but that means interest rates. And numerically, we verified that there is an inverse relationship between bond prices and interest rates. And specifically, if the market rate is the same as the coupon rate, the bond will sell at par. Yeah? So a 5% coupon bond will sell at par if market interest rates are at 5%. Then we said, well, what if we take a bond with different maturity dates? So something that has more life to it. Intuitively, what should happen? Well, if you have more terms in this list and you change an interest rate, more terms are going to be affected the longer term. So the same change in interest rates should be more impactful for a long-term bond as it is for a short-term bond. We verified that numerically, and we found that this is exactly true. So this relationship is the same, but more pronounced for long-term bonds. Yeah? And then we still use the same table, the same numerical applications that we did, and we developed another relationship, which said, on the x-axis we have years to maturity, and this is the bond price. I should say bond value, but I think your book keeps saying bond price there. And we said, if you have a par bond, so one that is currently selling at par, the only way for a bond to sell at par is if interest rates are the same as the coupon rate. So if you have a par bond and you hold the interest rates constant over time, a par bond will maintain its value without changing it. Again, this graph represented the value of a bond over time, holding interest rates constant. Okay, so the par bond remains leveled at its current price. Discount bond has a tendency to appreciate, and a premium bond will have a tendency to depreciate, and I drew this wrong. Okay, so this is a premium bond, and this is a discount bond. So those are very important things, so make sure that as you study the valuation process, you arrive to those conclusions. Make sure you remember them, because those are conceptual questions you might expect in the exam, okay?
So is this gonna be more conceptual or more math?
So in terms of computational questions on bonds, I can ask you maybe 5-6 types of questions, that's it. And expect one of each, not much surprise. But in terms of conceptual questions, I can ask you a bunch. Okay, so what is the most important stuff? If you can explain this graph to somebody, you should be good to go.
Okay.
Clearly, you need to memorize all the features of a bond, you know, the call feature and all those things. Those are just definitions, you need to remember them. Those are other things that you need to know.
How many questions?
I have no idea. So I can give you a number, but I'll be making it up, so I'm just gonna be honest. I didn't write the exam yet. But I know what I'll put there. I mean, you need to know how to calculate the value of a bond. You need to know how to calculate the current yield, yield to maturity, yield to call, and realized yield. For sure, I expect those 5. No surprise. If I don't write one, it's because I forgot. But it's rare that I forget. So, questions about this?
Can you say those 5 things again?
No, not saying it. You will know. I mean, 1. You know 1. The remaining 4, we need to cover them. We're gonna do it now.
All right.
So whatever I'm gonna write on the board for the next hour is going to be on the exam. Yes, it's gonna be on the quizzes. So that's it.
Got it.
Questions? You're good? All right. Now, it's all nice that we can compute values of bonds, but let's suppose I want to buy a bond. The way data is presented to me as a possible bond investor, they're just gonna give me the characteristics of the bond, so the coupon rate, date of maturity, and then a price. So how do I know if I want to buy this bond or another? The only way to compare is by calculating the interest rate that is embedded in the bond. So in real life, many times you will be doing the opposite calculation as this. You know the price, and you want to figure out what is the interest rate. Mathematically calculating that is very difficult. And so the first attempt at doing that is by using something called, first of all, we are talking about bond yields. The first attempt is called the current yield. Now this measure is easy, but not quite precise. So they came up with one more precise called the yield to maturity. So this is the rate of return that you get if you hold the bond until it matures. But then with some bonds, we might be prevented from holding the bond until maturity because our investment on the bond can be interrupted based on the will of the issuer. What kind of bonds am I talking about?
Callable bonds.
Callable bonds. So if you're dealing with callable bonds, you need to be able to calculate the yield to call. Now, after we have invested in the bond, and we want to see how well we did with the bond investment, we need to calculate something called the realized yield. So those three measures are measures that you calculate before you invest in the bond, so before the fact. And the realized yield is something that you calculate ex post, after you've invested in the bond. Okay? So when I'm investing, I might be interested in the first three measures, and after, when I got rid of the bond, or when the bond matured or whatever, I might want to know how well I did by calculating the realized yield. Okay? Computationally, the realized yield is by far the most complicated. And now let's see how the other ones are. The first one, current yield, is defined as the yearly coupon divided by the bond price. And of course, times 100% to convert it into percentage. So let's think about what could be the problem with this measure. We talked about zero coupon bonds, right? What are they?
Bonds.
Zero coupon bonds. They're bonds whose coupon is
Zero.
0%. So those are bonds that don't make any coupon payments. So they are bonds that sell at a very deep discount. Okay. So as an investor, if I think that the fair rate of return for that investment is 10% per year, I'm gonna price it in such a way that if I'm promised $1,000 10 years from now, I get a 10% discount for 1 year, 10% for the next, and 10%. So working out backwards, I use that number to figure out what is the price today. So that if I invest in that bond at the price that I'm calculating, I will experience a growth of 10% per year. Does it make sense? So let's suppose we're dealing with a zero coupon bond. It's one that sells at a very steep discount. What is the current yield of the bond? The yearly coupon is zero. The bond price is going to be some number, positive. So according to this measure, the return of the bond is zero. It's clearly not true. That bond gives me value and wealth through its appreciation over time. You agree? So this measure is not focused on completely ignores that this bond is appreciating over time. It only focuses on the income side of the bond. ignores whether the bond appreciates or depreciates. So if you're dealing with a discount bond, this measure of yield tends to understate how well you're gonna do with the bond, because it's ignoring that this thing is going to appreciate over time. What do you think is gonna happen if you're dealing with a premium bond?
It's gonna overstate.
The income is very generous, but what is happening to a premium bond over time? It's
Depreciating.
going down in price, so this measure will overstate the returns that you're gonna get from the bond. This being said, if you're dealing with a bond that is selling near par, the simple calculation is pretty decent in telling you what is the yield of the bond. Okay, it's pretty accurate. But the moment you're dealing with progressively larger premiums or discounts, this measure is progressively more and more inaccurate. Questions? You good? All right. Yield to maturity. Write it down. The yield to maturity is the rate of return an investor will earn. Is the rate of return an investor will earn, provided two conditions are satisfied. Is the rate of return an investor will earn, provided two conditions are satisfied. One, the bond is held until maturity. So condition one, the bond is held until maturity. Condition two, each coupon is reinvested. Each coupon is reinvested at a rate equal to the yield to maturity.
Could you say them again?
I'm gonna say it again, absolutely. So, the one from the beginning. The yield to maturity is the rate of return an investor will earn, provided two conditions are satisfied. Condition one, the bond is held until maturity. Condition two, each coupon is reinvested at a rate equal to the yield to maturity. You good? You good? Anybody? Can you repeat it?
The yield to maturity is the rate of return when
Oh, you have to repeat the document.
Yeah, you were on the right track.
Go ahead.
an investor will earn provided two conditions. The bond is held into maturity and each coupon is reinvested at a rate equal to yield to maturity.
Good. You good? Alright. As an investor, which of the two things can I control, if any?
How much money you spend?
Out of those two things. So I bought the bond already at whatever price.
You can control each
If
coupon.
you reinvest or not.
So let's suppose I calculate the yield to maturity and it comes out to be 7%. I haven't told you how to calculate it, but let's assume that we know how. So I'm kind of forecasting that by investing in this bond, I'm gonna get 7% return per year. But this measure makes two assumptions. The first one is what?
That it's held onto maturity.
If I buy this 27-year bond, I'm gonna keep it until it matures, the next 27 years. What else do I need to do? Every time I get a coupon, what do I have to do with it?
You
You have to
reinvest
reinvest
it.
it. at
Reinvest it.
maturity.
At what rate?
At the yield.
Yield to
The yield to maturity we calculated was 7%, so I have to reinvest it at 7%. Now, again, which of the two is under my control? The first one,
Yep.
holding the bond until it matures. Is it under my control?
Yes.
Be
Well,
careful.
It is if you only choose bonds you know aren't callable.
If I'm dealing with a straight bond, yes. If I'm dealing with a callable bond, then it's not up to me to hold it until maturity. If it's not called, I can, but if it's called, then I have to give it up. So that measure falls apart at that point. What else? I get a coupon every 6 months. What am I supposed to do with those coupons?
Reinvest
Put it back in.
Reinvest it. I have to reinvest it at what rate?
at
Yield.
the
7%. I need to find an investment that gives me 7%.
Mhm.
What do we know about interest rates over time? Are they stable or they fluctuate?
They fluctuate.
They're going to fluctuate. So our ability to reinvest at 7% depends on us up to a certain point. Okay. So it would be interesting to know what happens if interest rates go up. Are we gonna be better off than 7% return per year? Or are we gonna be worse off? Eventually, the realized yield is gonna tell us that. So how do we calculate the yield to maturity? The yield to maturity is calculated by looking at the bond price. You read that. You set that equal to the sum of the present value of the coupons. So you have, those are all numbers that you have except for R. So I'm gonna take these. And solve for R. So mathematically is, basically, you cannot come up with a closed solution, so an equation that gives you the value of R. You have to use numerical methods to figure out what R is. And for numerical methods, I mean, when you do this with a calculator, the calculator will pick a number for R, calculate the right-hand side, and compare that to the left-hand side. If the two numbers are not the same, it's gonna pick another value for R. And it's gonna keep doing that until the right-hand side is equal to the left-hand side, okay? So how do we do the financial calculator? With 5 buttons. So we're looking for the interest rate, and it's gonna be the number of coupon payments. PV is minus the price of the bond. This is the periodic coupon. And this is par. So those are all the pieces of information that you have. You will have to enter those in the calculator, and then have the calculator figure out what the interest rate is. Once you solve for the interest rate, if you're dealing with an annual bond, the answer that you get is directly the yield to maturity. If you're dealing with a semi-annual bond, you're gonna get the periodic interest rate. So it's only for the 6 months or 3 months or whatever type of bond you're dealing with. Okay, so this is going to be your periodic yield to maturity. Yeah? Questions? The yield to call, you can think of it as an equivalent to the yield to maturity, except instead of looking at you holding the bond until it matures, you're holding the bond until it can be called for the first time. So many bonds come with a deferred call. So the bond is issued today, but it can be called, say, 3 years from now. And so the 3 years from now is going to be your assumed holding period in the investment of this bond. So this only applies to callable bonds. Hold on. And it would require a small modification to the inputs. You have N, IY, PV, PMT, and FV. For N is the number of coupon payments until callable, or until called. This is the rate that you're looking for. This is the price. This is the periodic coupon. And instead of getting par, Some callable bonds will give a different amount than par if they're called, and that is called the call price of the bond. That's the only difference between those two. So it's the number of periods and what goes here. And you had a question, sorry.
With regards to my annual payments, do you just like double the in?
We're gonna do it in a second.
Okay.
What does it say under PMT?
Periodic coupon. It's all imaginary because I didn't write periodic, but in my head it was periodic. So it's periodic coupon for payment. Yes.
Just a quick question about the functionality of callable bonds. For like, if it was like a 9-year bond, callable at 3 years, is it callable between 3 years and 9 years, like at any point in that time period, or is it
There is an
just
actual
callable?
schedule, and this schedule can be yearly or whatever they write on it. The ones that I've seen recently, those are CDs, they were not bonds. First of all, for the bonds, the majority of the bonds I found, they're all callable. Why would I want to have callable bonds now? Think about it. If you are a business, you're borrowing money. What kind of interest rate environment are we in? Low interest rates or high rates? High rates. So if you're issuing a 30-year bond, you might want to issue one that is callable, just in
else-
case interest rates are going to drop in the next 20 years or
If
so.
you can't pay the full par.
So yes, even though they might be penalized because they might have to pay a higher price here, that's one way to handle it. Okay. CDs, if you're looking at CDs that are more than a year, quite a few of them are callable. How can a business convince me to invest in a callable CDs instead of one that is not callable?
Discount, right.
They give me a higher rate for the callable ones, right? So I'm guaranteed that for 1 year, I'm gonna get a little bit of a higher rate. But then maybe next year, I might have to give up the bond. Okay, so this is the way bonds are selling right now. Another issue for, I don't know if I mentioned that, for if you're a bond investor, if I look at one particular issue among large issuers of bonds, I might find that they're selling a bond for $998, and they calculate a yield to maturity of 4.75%. And I think, hey, that is a good bond. Maybe I don't want this bond to be callable, so out of the possible list, I pick the one that is not callable. But then there is also something called the quantity, and the minimum quantity that you can buy. So this has to do with the possible investors in the secondary market. And maybe the quantity available is 150 bonds, but the minimum quantity is 50. So if I'm a small investor, if I'm trading in my IRA account,
You have to buy the 50 bonds, you can't buy 10.
I cannot buy 5, I cannot buy 6, I have to buy a minimum of 50 bonds. But typically, when you're starting as in an IRA account, you can only deposit a relatively small amount of money. It varies by age, but you're looking at about $7,000 a year or so. There is absolutely no way you can buy those bonds because you need at least $50,000. Okay, so investing in bonds and looking at bond strategies might be applicable to large traders, but not necessarily to small investors. So, like, also as a small investor, if I'm trading this for somebody's account, it might not necessarily be wise to concentrate $50,000 in a single bond. If the company goes bankrupt, this guy is gonna lose his money, and it's too much concentration in investments. Okay, so that's something to keep in mind if you're actually thinking about buying and selling bonds. All right. So let's do a couple of examples for those type of yields, and then we're gonna do the realized yield. Example. A bond is selling at $1,038, has 27 years maturity, coupon rate of 4.75% will be callable in 3 years for 1,050. The questions are: A, calculate current yield, yield to maturity, that's an odd M, and C, yield to common. Now, if I don't tell you anything, assume that coupons are paid
1,000 bar.
annually and par is 1,000, okay? So, 1,000 par. Annual coupon. Yep. All right, so let's start with the first one, current yield. Coupon divided by
Bond price.
bond price. So what is the yearly coupon of this thing?
47.5,
4.75% of
1,000.
1,000. So let's calculate the coupon here. Is 4.75% times $1,000. 47.50 divided by the price of this
10.38.
thing is 10.38. Whatever you get times 100 to state it in percentage. Yeah. So what do you get?
4.6%.
4.6%. You agree? Yep. Not too bad, right? Just a definition. Based on this, before you do anything else, is the yield to maturity gonna be higher or lower than that? And how do you figure it out? Is the yield to maturity going to be higher or lower? Think about what we said about the current yield.
It's gonna be
What kind of bond is this? Premium or discount?
premium.
Premium, right? The price is above par. If it's a premium bond, then this bond tends to do what? Depreciate. So the current yield tends to overstate the yield to maturity of this bond. The difference is probably not gonna be that much because the premium is not huge, but if you look at more digits, perhaps you'll figure out that's the case. All right, yield to maturity. And IY, PMT, PMT, and FB. We are looking for the rate,
27,
27 payments, good,
negative 1,038.
38. Payment we said is 47.50. And mark. What do you get?
4.5.
4.5, do you agree? Yeah? Questions? What about the yield to call?
4.9 is what I got.
B is callable in around 3 years. This thing is still selling at 10.38. Coupon is 47.50. If this bond is called, we get 10.50 instead of par. Yeah, so those are the numbers that go in it. And what do you get?
4.9%.
4.9, do you agree? Yep. So, on the exam, expect one of each. In the quizzes, expect one of each. One thing about the quiz, the D12 only has basically addition and subtraction and very elementary functions, doesn't have the financial calculator embedded in it. So the way I had to code the questions was to kind of get around this. I cannot enter this information in D2L. So I have an approximation to the correct answer. An approximation is not the exact answer. So if you're doing the problems in D12 where you calculate the yields except for the current yield, you're calculating the yield to maturity and the yield to call, I will be off a little bit. So my answer is gonna be off. Yours is gonna be, if you do things correctly, it's gonna be accurate. So to compensate for me being off, I am giving you kind of a broad window within which I accept an answer being correct, because the center of the window, which is my answer, is gonna be a little bit off. I have no other way to handle it. One way to fix that is to force you to buy the stuff from the publisher, which is gonna cost you $200 for the semester, which I don't think is worth at all. So be aware of that. If you think you're gonna be off all the time on calculating the yields, it's probably not you, it's me. If I'm marking the question, your answers incorrectly, and there is a massive difference between the two, it's probably you. So if you have a doubt on that, before you go crazy, come and talk to me and I'll check your work. Questions?
Are we gonna have any questions on the exam about the valuation of the firm, like computation?
For the, you're gonna have the dividend discount model, so anything that is in the quizzes, computational, yes. There is one problem about the sustainable growth rate. I did not talk about that in class. I want you to do it by looking at the example in the textbook. That is extra credit in the quiz. I will not ask you that in the exam. So if there is one question that is extra credit, and is where you have to calculate G from the ROE, that is an extra credit problem. It will not be in the exam. Yeah. Questions? So let's change things a little bit, and let's assume, refer to the previous problem. And the question is, what is the yield to maturity if the bond makes semi-annual payments? Okay, so it's the same question, but now the payments are semi-annual. So the answer is the same. The many calculations are carried out the same way. But
4.56.
remember, slow down. It's exciting, but I'm going slower. N is what? Is not the number of coupons, it's the number of coupon payments, right? If this thing makes some annual payments, the number of coupon payments are actually split into 2 installments, meaning that they double. So the bond has 27 years to maturity, so 27 times 2, the number that goes here is 54. You're still paying 1038 for the bond, but now each of those yearly coupons is split into 2 halves, and so the 4750 is now half of that. Yeah. So this is 4750 divided by 2, which is 2375. And when the bond matures, you still get the bar. Yeah. So what answer do you get from those calculations?
The periodic.
2.3, give me one more decimal.
Oh, 2.25.
2.25%. Now think about it. Before I want to give you a way to figure out if you're making a mistake here. This bond is near par, right? So the yield to maturity is probably gonna be somewhere close to the coupon rate. And it's selling above par. So that means that the yield to maturity should be selling above par. here. So the yield to maturity should be somewhere near here. If this is 4.75, it's definitely not gonna be 2.5%, right? So the answer that we got is totally unreasonable for this type of bond. So that should give you a hint that what you got here is the interest rate only for 6 months. We're scaling this problem into 6-month periods. So every time you give a yield, it has to be annualized. So your correct answer is going to be this times 2, which is 4.5%. Okay? So when you're dealing with semi-annual and annual, the answers are going to be very similar. They're gonna be off a little, but typically they're very similar. So if you do the calculations like this to get the reference, it's fine. Just do the calculations as the bond annual, and then do the calculations as if the bond was semi-annual, and the difference is gonna be very, very little. Okay? This is clearly a sign that this, if you put this as the answer, you're gonna be off quite a bit. Okay, does it make sense?
So when it asks and it mentions like semi-annual payments, I mean, we just multiply by 2 anyways? Or?
This is the proper way to do it, but if you don't remember, just do it as if the bond was a straight bond, annual bond, and this is gonna get close to the correct answer, but it's not gonna be the correct answer, but very close. Okay, so if I have to take a guess, I would just pick this as the starting point for my guessing. Does it make sense?
Yeah.
Questions? So this old stuff that you've seen in Intro to Finance, right? Somewhat. So if you've taken the class with me, there is absolutely nothing new up to this point. What's new? Realized yield. This is complicated. So the realized yield is a measure of what you actually have done in terms of performance with your bond investment. So the general idea of the realized yield is this. This is now. That's when I'm either the bond is matured or I'm selling it. And now I have some money. Some money is from selling the bond, but also the value of the past coupons that I collected over time. And this is many years ago when the bond was acquired. So this is my bond investment. And over time, I collected some coupons. And some of those coupons were reinvested. Some maybe were not reinvested, who knows what you did with them. But overall, they sum up to a certain value. And what we want to figure out is my present value was my initial investment. Over time, I end up with some future value, which is the sum of those two. So it's my wealth right now at sale of the bond. I know that this occurred over a certain number of periods, and what I want to figure out is what is the rate of return that makes this initial investment grow to be this much. Okay, so this is what the realized yield is. 5 years ago, I bought this bond for $780. Now I'm selling the bond. I collected coupons for all those years, and I have this much money. What rate of return did I get from this bond? Spent $750, I have $1,300 now. The realized yield answers exactly that question. It tells you the rate of growth of your initial investment. So how do we find the answer?
What does that say under the future value?
Wealth, mass, sale of bond. So this is the general idea of what we're trying to do here. So how do we do it? To compute the realized yield, we first need to calculate the wealth of the investor. At the closing of the position. So this means at the end of this time period. And the way you calculate the wealth of the investor is by considering each coupon, the rate at which this coupon was reinvested, for how long, and that gives you the future value of this coupon. Repeat that for all coupons. Repeat that for collecting par or selling the bond. And this is gonna be some other amount. And your wealth is gonna be the sum of those. So this is what you have now after you reinvested the coupons in this bond. Okay? Question? You sure? I know I stood with my writing, and you can say it. It's okay.
I don't really see what's the difference between the first and second line after that.
Right here, they're the same.
They are the same.
Actually, the only thing that should change is the subscript here. Because you are talking about the coupon invested at some rate and another coupon invested at some other rate for a different amount of time.
Okay,
Focus on the general idea.
got it.
Sorry, can you repeat that? So you're taking the coupon rate and you're getting the future value of it?
So you're collecting coupons, you're reinvesting them at these rates, and they're now worth some amount. Yep? You repeat that for all the coupons that you collected. And then you add them up together with what you got from selling the bond, and that tells you how much is your wealth at the end of this bond investment. Yep? So let's consider the simplest possible case where you don't reinvest the coupons. I collect coupons for 3 years. What would be my wealth? It's gonna be the sum of coupon 1, 2, and 3, right? They're not invested, and then whatever I got from selling the bond. So my wealth is the sum of what I get from selling plus the collection of the coupons in the most elementary case. Yeah? Okay, so once you have the wealth, the second step you want to treat your initial investment as a lump sum that allowed you to generate the wealth at the end. So here is an initial investment. Typically is gonna be your purchasing price of the bond. And this is your wealth at the end of the investment, which is what you calculated in the first step. The realized yield is gonna be this number right here. This is the number of years you held the position minus the price. This is gonna be 0, you treat that as a lump sum, and this is your wealth at the end. Okay. So, what you're doing mathematically is quite complicated, because what you're doing is calculating the, I don't want to get there. Never mind. Questions? So let's try it. Just graphically, we're gonna try to set it up, and then we'll do it numerically. Example. 5 years ago, you bought a bond for B0. It just matured. And paid coupons starting 1 year after your purchase. And the question is, what is your realized yield? If coupons were not reinvested? Okay, so 5 years ago you bought a bond for $0. It just matured and paid coupons starting 1 year after purchase. And the question is, what is the realized yield of this bond? Well, actually, I should say the realized yield of your investment. Yeah? So the first thing we need to do is draw a timeline to make sense of what's going on here. So this is now, and we're going back in time. A year ago, 2 years ago, 3 years ago, 4 years ago, 5 years ago. You agree? 5 years ago, what happened?
You bought it.
I bought the bond for $0. Year 4, what happened? 4 years ago. Collected the first coupon,
Second coupons are.
one each. What happens at maturity?
You cut the fifth coupon and also the par.
You collect the coupon and then par, right? Can you tell me what is your wealth? Well, the money that you just collected is coupon and par, but somehow you also collected coupons in the past. So what is your wealth? Well, these must be added here, these must be added here, these must be added here, and so on, right? So what is your wealth? Your wealth is gonna be par plus
The
5 coupons. Yeah? So how well did you do in your bond investment? Well, this is your present value. This is your future value. How much time elapsed? 5 years. We want to figure out the interest rate. Okay. So the way you do it in the calculator is N and Y, MT, and FB. The interest rate is what we're looking for. N is gonna be your 5 years. Your present value is minus $0. You're treating this as a lump sum, so payment is going to be 0. And this is gonna be your wealth, which is, in this case, is gonna be par plus 5 times the coupons. Yeah? Questions? You good? Are you ready for one that is more involved? Example. Four years ago, you bought a bond for $1,000. The bond at a coupon rate of 5%. And it just matured. And you reinvested the coupons at the coupon 1 at 6%, coupon 2 at 10%, and that's it. And the question is, what is the realized yield for your investment? So the remaining coupons, if there are any, those are assuming that, since I don't give you a rate, assume that they were not invested. So start with the timeline. Now, a year ago, 2 years ago, 3 years ago, 4 years ago. Yep. What coupon are we collecting here? Coupon rate times par
$50.
is 5% times 1,000, $50. When we bought this thing, how much did we pay?
You paid $1,000.
We paid 1,000. So what kind of bond did we buy?
We bought one that was,
The price is the same as par, so what kind of bond is that?
par.
It's a par bond,
Yeah.
right? All right, it's gonna turn out to be useful in a minute.
Mm.
All right, so now this bond matured, so what do we get?
We
A
get
maturity.
1,000.
You get par and the last coupon, right?
150.
So this is maturity. Do you agree? So let me clarify this a little bit. Instead of coupon 1 and 2, let's call this coupon -3, coupon -2, and let's add the last one, coupon -1. We make it 15%, so it's more clear what I'm talking about. Okay, that was not clear enough, was ambiguous. Do you agree? So, what do we do with the coupon that we got last year?
Times it by the,
We reinvested and we collected 15% on it, right? So, how much is this thing worth today?
50 times.
This is the 50 times 1 plus 115. How long was the money invested?
A year.
Only 1 year. So it's 50 times 0.115 is 57.
57.5.
Do you agree? What about the coupon we collected 2 years ago?
That one, 50 times 1.36.
Well, this was reinvested at 10%,
Oh,
but for how long?
2 years.
2 years. So what do you get?
55.125.
Do you agree? 55.25? Yes?
125.
1, 2? Okay. And what about the coupon from 3 years ago? This was reinvested at 6?
Yeah, 59.55.
So 59.50? Yes?
Yes.
All right. So what is our wealth?
Those.
It's the sum of all this stuff, right? So add them all up. What do you get?
You get 1,227.55.
155? Yep. So we invested $1,000 and over the course of this time collected coupons, collected interest on the coupons. you agree with this number?
Are we adding the 15,000 too?
We are adding all of those.
Okay.
Yeah. Yeah. So our initial investment of $1,000 is now worth $227.55. So what is our rate of return? N, Y, V, N, T, and F. V. Our investment took 4 years. The interest rate is what we're looking for. Present value, we spent 1,000 for this thing, and we end up with 1,227.55. What do you get?
5.26.
5.26%? You agree? You good? Anything different?
I'm not sure.
I
When I added up my things, I was getting 1,222. Yeah.
1,222?
Yeah.
Uh-oh. Uh-oh. 1,222, sorry guys.
1,222.12.
12.
Yeah.
So the only thing that changes is this number right here, this goes here, right? And the interest rate you're gonna get is slightly lower than that. What do you get?
$5.14.
514? Do you agree?
Yes.
Questions? So what is the realized yield telling you? What kind of information does it provide? How well you did with your bond investment, right?
After the
And after considering your investment and everything else. In this particular example, what was the yield to maturity of this bond when it was bought? Is selling at par? When is that the price is equal to par? Is when I erase the graph, but is when the yield to maturity is equal to the coupon rate, right? So had we calculated the yield to maturity at this point, we would have said the yield to maturity is 5%. In order for you to earn 5% from the bond investment, what do you have to do? Hold it until maturity, we did that, and then what else? Reinvest the coupons at a rate equal to 5%. We ended up earning 5.14%. So you're actually better off. Why?
Because we invested at a higher rate.
Each coupon was reinvested at 6, 10, 15 instead of 5%. So if interest rates go up over time, what happens to your reinvestment of the coupons?
The increase.
It's likely to give you a higher return, right? The environment in which you are investing is favorable to you. So that makes you generate more wealth. But at the same time, if interest rates go up, what happens to bond prices? They go down, right? So an increase in interest rates has two effects on bonds. One is that makes the reinvestment better. The other one is it makes the price lower. You can think of a point where this trade-off kind of washes out, and that is related to the duration of a bond. If you have heard that term in other classes. Okay. Questions? So what do you need to do? For the purpose of the exam, those are all the calculations you need to do on bonds. Calculate the value of a bond for a regular bond and for one that makes some annual payments. You need to learn how to calculate the current yield, yield to maturity, yield to call, and realized yield. Okay. The realized yield, we're only gonna do it for yearly payments for simplicity, because otherwise it gets too complicated. It just gets longer. So in the quizzes, you're gonna have one problem each, give it or take, make sure you're familiar with all of them, and practice them until you can do a problem in under a minute, and you're good to go.
I just didn't realize, the last question on the quiz, on the most recent quizzes, it was this.
It was this, yes.
Yeah.
There was the one thing that was missing from the lecture, yeah. So this is it. I mean, we are done with bonds. On Wednesday, we're gonna start the basics of portfolio theory. Make sure you come to class because reading the book is painful on that topic.
Thank you. I think it's running out, or I don't know what's going on. It says it has stuff, but
It's still there.
I know. It's just like.
They're better at writing